Okay. So in the last class we did this question. I hope you people might have solved the equations and come to the answers, right?
I got a decimal answer.
Doesn't matter. Nobody said the answer will be perfect. The answer may be in decimals, no problem. So shall we do this question or shall I leave the equation solving part to you people? Okay. So I'll give you a similar question of this type, and I will try to do it using nodal analysis. Or we'll do both. I'll solve the equations for you people. Don't worry. We'll be not wasting time.
Okay, sir.
We'll not waste our time on solving the equation. The It's a similar question which we did in the last class. The values I'm saying. Okay, guys, can you see the whole thing? A, B, C, D, E. Now the question is find the current through each of the resistors through each resistance in the given circuit. Please remember why I'm teaching you different approach to the same problem so that at least whatever you are comfortable in, whichever method you are comfortable in, use that. KVL and the second one is nodal. चलो शुरू हो जाओ. So KVL is a homework for you people. Will you be able to do the KVL part or shall I solve it, guys?
So can you show us the question one more?
Diagram I'll show you, Tani. No problem. Right. It's the similar question which we did in last class, but I want you to solve the question with the help of nodal analysis as well as KVL. So let's do it in class. No problem. We'll do it quickly, okay? So, guys, first of all, which battery shall I choose from the initial current to come out? Which battery? 10 volt, 8 volt, 6 volt.
10 volt.
Generally, we take the biggest battery. So let's take out the current from this battery. Let's say the current is I. So this current I goes over here, passes through this 4 ohm resistor, and then it breaks into two parts, right? Let's say this is I1. Then what will be this? What will be this? This will be
I minus I1.
I minus I1. So this I minus I1 current will pass through this 5 ohm resistor through this 6 volt battery, and it will come back to here I minus I1, right? Similarly, this I1
Yes.
will travel through 10 ohm resistor, will travel through 8 volt battery, and then it will come over here, right? Here I minus I1 and I1 will combine again and become I. So can you see whatever current you left from one battery is reaching the battery again? So is my current distribution correct?
Yes. Yes, sir.
Yes, sir.
Okay. So first of all, let's take a loop A, B, C, F, A. Sir, why are we choosing loop this? Because this loop looks small, right? Acha, by the way,
Hmm.
one more thing, guys. Um, how many equations do you need to make depends upon how many variables you have taken. है ना? For example, how many variables have you taken over here? You have don't know what is the
2.
value of I and you don't know what is the value of I1, right? So how many variables are there?
2.
How many equations will be needed minimum?
2.
So basically, how will you do this question now? Let's make it. चलो शुरू हो जाओ. Let's start walking from A to B. When you start walking from A to B, plus minus. Guys, do you need a revision of Kirchhoff KVL?
Will be positive. 6.
Maybe नहीं. एक बार मैं revise करवा देता हूँ. Because I want the answers to be perfect. तो उसमें maybe नहीं होना चाहिए. See, whenever we enter from the positive terminal of the battery, then minus C. Okay? Negative terminal of the battery, plus C. Whenever we have a capacitance, then the same rule as the battery. Whenever we have a resistor, if we are going in the direction of current, then minus of IR. In the direction opposite to current, then plus IR. Is this clear? It's clear, guys? Now apply. Yes, 6 volt. Plus minus.
Plus.
So plus 6. And we are going from B to C. Yes, tell me.
So plus 5.
Plus 5 into I minus I1. फिर उसके बाद we are going 4 ohm.
Plus 4.
Plus 4I. If you remember the current passing through this is I, right? So plus 4I. Then battery. Everyone?
Minus 10.
Minus.
Yes, minus 10. Guys, can you please unmute everyone? Please unmute everyone. Abel, Arya, there. Please unmute everyone.
So I took a different loop.
No problem. Equations, when you will solve it, no problem. If you want to solve it on working or only, no problem. Please, I want everyone to speak. It's not like only few of the students will speak. सबको बोलना पड़ेगा. वैसे ही वैष्णवी सबका नाम नहीं लूंगा मैं. Everyone. Satvik, you know, told me the mic is not working. Guru. चलिए. So minus 10, right? Yes or no?
Yes, sir.
Yes, sir.
Now, when you reach point F, and then there is nothing in between F and A, right?
Mhm.
So we'll come back to this point, right? So basically, this will be equal to 0.
0.
0.
Yes or no? So
Yes, sir.
this is the first equation. Can you make the first equation? Plus 6 plus 5i. So 5i plus 4i, 9i minus
Minus 5I1.
5i1 is equals to minus
4.
6 plus
4.
6.
Minus 4.
So 4. I shifted it to the right. Sir, my sister is taking tuition online, so it's okay for do not. ठीक है भाई. Okay. But I want, whenever I want answers, I want you to unmute. है ना, Abel? So this is the first loop, first equation. Now, which loop shall we take? Yes, guys, second equation. Which should be the second equation? Let's take B, C, sorry,
D, E, F,
C,
C.
D, E, F. Huh? Yes, tell me, tell
C,
me.
D, F, C.
C, D, F, E, C, D, E, F.
Yeah,
Yeah.
C, D, F.
Okay. So, yes, tell me. C to D. You're going in the direction of current. Going in the direction of current. Plus, minus.
Minus 10 I1.
Minus 10 I1. Then battery, positive terminal you are entering.
Minus 8.
Minus 8. Then when you come to E to F, nothing is there. Now when you go from F to C, you encounter a battery and a resistor. Battery, negative terminal.
Plus 10.
Plus
Plus
10.
10. And then, you know, current, direction of current.
Plus 4.
Wrong,
Plus-
minus.
Minus 4I1. 4I.
Equals to, is this clear? So you make the second equation. The second equation will be minus 4i minus 10i1 is equals to
Minus 2.
Minus 2.
No. When you move it to the left hand, yes, it is minus.
Yeah, it's minus 2.
Minus
It
2.
is minus. So this is first equation. This is second equation. Can anyone solve? And please don't solve. I have a scientific calculator with me, so I'll solve it for you. Don't worry. So on solving 1 and 2, yeah. Tell me what are the equations? Unknowns are
5 by 11.
two unknowns, 5 by 11. Let me check now. 9 minus 5, 4. A2 is minus 4, B2 is minus 10, C2 is minus 2. And how would we write it in this form? 5 by 11. So on solving I, 5 by 11 amperes,
Yes, sir.
I1 is 1 by 55.
Yes, sir.
So when you solve it, you will get this. I'm not solving it in front of you, okay guys? Because it will take very much long time to solve the equations here. So it's better if you know just give me 2 minutes, guys. So I is the 5 by 11 and I1 is minus 1 by 55. So see, both are positive. What do you mean by both are positive? When you know the solved it, both are positive, that implies you have guessed the direction correct. If you would have guessed the direction wrong, automatically in the answer there would be a negative sign. Okay.
Mm.
So next question, whenever I'll take it, such a way that answer will come negative. So at least my concept will also get correct. So I is 5 by 11 ampere, I1 is 1 by 55 ampere. Now you've got the value of I and I1. Acha, what is I minus I1?
24 by 55.
24 by 55. Are you sure?
Yes, sir.
Okay. So everything is coming positive, that implies every direction is correct. So when you solve, so what is the current through 5 ohm resistor? What is the current through 5 ohm resistor? I minus I1, right?
24 by 55.
So that is 24 by 55. That's the answer. What is the current through 10 ohm? I1 is
1
it?
by
1 by
55.
55. And what is the current through 4 ohm?
5 by 11.
So this is how you do it using KVL. Let's try to do it using nodal. I need to draw the question again. It was already taken. I'll draw it again. 5 ohm, 4 ohm, 10 ohm. Battery 10 volt, and here it is 8 volt. And here it was 6 volt. Was this the question? Yes, was this the question, guys?
Yes, sir.
Yes, one more thing, very important thing which you need to understand. In case of nodal analysis, when you mark these joints, over here, sir. So one common question which I observed from people is basically, sir, why have you marked this also as a joint? This is not a joint. Then why have you marked it? See, it's like in nodal analysis, it is very important with that in between any two nodes there will be only one element. In nodal analysis, between two joints, there should be only one element.
Mm.
It's very necessary because it will make the problems otherwise complicated. Only one element. You understand what element means, right?
Yes, sir.
Element can be a battery, can be a resistor, can be inductor, capacitor, etc. So this is the question. Now, guys, do you remember I taught you SS method also?
Yes, sir.
I'll be giving you one question based on that today. And capacitor, I'll include the capacitor as well. So Tell me. First of all, which shall be taken as 0? According to you, which joint shall be named as 0? Always try to give that reference 0 to the negative terminal. Can you see the negative terminal of the battery? Here in this question, the negative terminal, has been connected over here. Can you see? All the negative have been connected together. I can name this as 0.
Yes, sir.
If I am naming this as 0, what should be the potential of this point?
10.
10.
10.
Very good. What should be the potential of this point? Can you see? Here, this part. Can you see 6 volt? This battery will rise
6.
up the potential by 6 volt. Go ahead. And similarly, this will become
8.
8 volt.
What about this? Can 6 go over here? Can 8 go over here? Guys, are you sure now? I've taught you
No.
SS, right?
No, sir.
No.
No, sir.
I have not taught you SS as of now.
Yes, sir. No, yes, sir.
No, sir, you have taught.
I have taught, no? SS shift search method I have taught, no?
Yes, sir.
Unnecessary wires, no element in between. So that will be so the same concept. Can you see? I told you SS is based on nodal analysis.
Mm.
So can you see? If this is 6, I can't name this as 6. If this is 8, I can't name this as 8. Why? Because there is a resistor. There is a resistor. So I have to name it something else.
Yes, sir.
So I named it X. Okay. Okay.
Mm.
So now, can you see the
Yes,
total
sir.
Yes, sir.
outgoing current at X should be 0? I don't know what is VG of X, but I won't even bother to how to see whether the current is incoming or outgoing. I told you, since the variable which is included. Wait a second. थोड़ा धीरे धीरे बढ़ो. So since there is a variable included over there, so I don't know what is the direction. So I'll just say total outgoing current should be 0. So can you see X minus 6 divided by
5.
plus X minus 10 divided by
X minus 8, yeah.
X minus 10 divided
Okay.
by 4 plus
4.
X minus 8 divided by
10.
is it?
Yes, sir.
When you solve this equation, you'll get X as 90 by 11 volt. You
So
can
I got 72 by 11.
You got what?
72 by 11.
Are you sure?
Yes, sir.
Let me check.
Let's check once
5,
again.
4, 10. What is the least common multiple? I think 20.
20.
20.
4
No, sir. It's 90 by 11.
90 by 11. Okay?
Yes, sir.
This is your X. Now, what is the current through individual? What is the current through 5 ohm, 4 ohm, and 10 ohm? So the current through 5 ohm is X minus 6 by 5, which is basically 90 by 11 minus. So let me calculate what is 90 by 11. So 8.18 minus 6, 2.188 divided by 5 is 0.436 ampere. So the current through is 0.436 ampere. This is equal to how much? 24 by 55. Okay. The
Yes, sir.
current through 4 ohm resistor is X minus 10 divided by 4, so which is basically 8.188 minus 10. So, so 8.181818 minus 10, which is minus 1.8188 divided by 4, which is equals to minus of 0.4545, which wait a second, 0.4545 4, 5, 4. Why did not happen? Why is 0.454 not showing in this thing? I think this should be 5 by 11, I guess. This should be 5 by 11. And with a minus sign. Why with a minus sign? Guys?
Opposite direction of current.
Exactly. Because we said कि 4 ohm say the current is outgoing. Right? We said no, X minus 10. We assume that the current is outgoing. But can you see from the answer itself it is coming negative? That implies whatever you thought that this 4 ohm is not outgoing current. It's incoming current. Is this clear? Are you
So in
getting
the
my point?
previous method, if you had got a negative answer, what would that mean?
What would that mean? That the whole branch in which you have supposed the current, the whole branch, the current will reverse.
Okay, and in this case, it means the direction is
The
different.
direction is so the same thing, no? The reverse is the opposite direction only. No? It means the same thing in both of the cases.
So it is not wrong, but the direction will be different.
Yes, direction will be opposite. And what is the current through? Last one is what? 10 ohm. So this will be x minus 8 upon 10, which is basically 8.181818 minus 10. 1.181818. How is this 2 coming at the end? I don't know. So ये हो गया. उसके बाद में divided by 10. So it will be 0.01818, which is basically 1 upon what? 1 upon
55.
Is this clear, guys? So it doesn't matter whether you use nodal, doesn't matter whether you use KVL, the answer is going to come the same. Have you noted down things? Everyone noted down along with me now?
Yes, sir.
Yes, sir.
Please remember, if the direction, if it is coming negative, if the value is coming negative, that implies the direction which we have guessed is wrong. So opposite is true. Okay, so we have guessed the direction was from x to 10, right? We have to guess the direction was from x to 10, but 10 to x direction. Okay. Shall I give you one more question to practice on nodal and all? Then I'll teach you open
Yes, sir.
circuit Kirchhoff. And then I'll give you one question based on capacitor circuit, pure capacitor. Let me just grab the capacitor notes. Try to note it down till that time. See, that is the plus point of having notes. I'll at least I have answers to any problem. Initially, I used to create a problem, and उसका आंसर मेरे को भी नहीं पता था. So, anyways. Hello, guys. I'll give you one more question on resistive Kirchhoff. Then we'll go to, we'll do one question on capacitive Kirchhoff. I'll just tell you exactly what is the difference. We'll do it with both the things. We'll do it with nodal as well as apply Kirchhoff. Okay? Shall I give you the next question?
Yes, sir.
Yes, sir.
Start. This is the question. The question is find the current in the 6 ohm and the 10 ohm resistor. Achha, whatever current is going through 10 ohm, that will be the current through 3-volt battery as well, right? Yes or no?
So could you repeat that?
The question is कि find, मैं लिख देता हूँ, I'll write it. Find the current 6 ohm resistor, and the second is 10 ohm resistor. Please remember the whatever the current which is passing through 10 ohm will be through 3 volt as well, because 10 ohm and 3 volt are in series, right? Are these two in series with each other? Yes or no?
Yes, sir.
So basically this branch, whatever the current will flow through this branch, that will be the 10 ohm and 3 volt. It will flow through both of them. So if someone can ask you what is the 3 volt battery, so the answer will be the similar as the 10 ohm resistor. Is it clear?
Yes, sir.
Answer same. Sorry. So let's start. Which method? Initial questions I'll solve it using KVL nodal both. Once you'll get acquainted with it, I'll just solve by one. Okay?
Yes, sir.
Okay. Let's solve it using KVL. So now, can anyone tell me which should be the current? Current कहाँ से निकालूँ बाहर? Where should I take the?
4.5.
Okay, let's take the current out from the 4.5 volt battery. So I will flow through this 3 ohm. Yes or no? Guys,
Yes, sir.
remember the steps. See, can you see over here? Every question in Kirchhoff has the same step. Badi battery, take out the choose the biggest battery, take out the current from that battery, distribute the current throughout the circuit, and then start using loops, apply sign convention, make equation solve. Khata. Every KVL question will go like that. Okay. So 3 volt. Yes, this same current I will come over here. Now what will happen to this I? This
Will
I
branch.
it
The
will
branch.
branch. So basically, let's how much current will go through here? Let's say
I1.
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 I'm
चलो ठीक है I1 ले लेते कोई दिक्कत नहीं no problem I1 this is
I minus
I
I1.
I minus
I minus 1.
so I1 current will flow through 10 ohm resistance, I1 current will flow through 3 volt battery, and I1 current will come over here. I minus I1 will flow through 6 ohm and will come over here. So this is I minus I1. Now this I minus I1 and I1 will collab again and become,
I.
and the same
I.
current will come back to the battery. Always remember your current distribution is correct when the same current reaches the battery. Okay, and please don't think like I said 4.5 से भी कुछ current निकाल दूँ. Let's take out some current from 4.5 and let's take out some current from 3 volt. No, don't use superposition over here. That will be done in college level. Not here. Here it will make your life very difficult. Okay. So anyways, so once this is done, then what to do? Choose the loops. Let's talk about this loop. I'm not writing the name of this loop. Is it fine?
Okay, sir.
So tell me what if I apply the loop. We are going like this. In which direction? Clockwise sense.
Yeah.
Okay.
Okay.
So let's move. First 3 ohm resistor
It'll be minus 3i.
minus 3i आगे
Then it will be minus 6
minus
I minus I1.
very good आगे
3 plus 4 minus 4.5e. Yeah.
plus or minus
minus
you are entering
Plus.
from negative terminal when you come from here you are entering from negative terminal plus or minus
Yes, yeah.
Plus.
plus
plus
है ना minus नहीं
Yeah.
equal
Plus.
second equation in the upper loop. Upper loop we are moving clockwise hmm? hello yes Guru tell me Guru
So,
yes tell me what is the equation for the second loop the upper loop we are moving clockwise okay
wait, 10 into I1
plus minus
or plus.
wrong we are going in the direction of current can you see current
Okay,
is
so
also going left we are also going left
minus,
minus 10
and
I1
then minus 3,
plus 3 minus 3
minus 7.
minus 3 again
So that's it.
loop
Okay, so there's 6 ohm resistor also. Okay.
6 ohm resistor as well
So plus 6 into
plus
I minus I1.
very good this is equal to so can I solve minus 9i plus 6i minus 2.5 and 6i 16i है ना yes or no yes or no guys
So what's the final
Yes,
answer?
sir.
just tell me the final answer
Okay, I'm not sure, but I got I as I don't know if I took the same distribution as
is
yours.
okay is your current what is the current through 10 ohm resistance what is the current through this branch
And I'm getting it as 0.
it's a correct answer
Okay.
so
I did by nodal analysis, I got 0.
yes perfect no problem that's what I'm talking it's up to you what you want to choose in competitive exams which method to go if you feel ease in KVL go with KVL if you feel ease in nodal go with nodal I generally prefer nodal why I prefer nodal because there is always one variable less अभी देखो in this question how many variables are there है ना two variables are there in
2
nodal there will
variable.
be only one variable generally it happens it's not necessary अब देखो let's solve
So
this
your voice isn't that clear, sir. I don't know if it's just
what
for me.
what
I can't hear you clearly. I'll even
Yes,
join
sir, your
after.
voice is not so clear.
अब clear है is it clear now no
Kind of.
connection maybe it's giving a problem that's why so when you solve it from here I will be 0.5 I1 will be in this case so from here I minus I1 will be so देखो what is the current to 10 ohm resistor and current is that is the answer to your question is this clear is this clear guys
Yes, sir.
now using nodal
So why isn't it flowing through the 10 ohm resistor?
because potential no this thing is no
Okay, yeah,
equal
it's
and opposite
equal, yeah.
Yes. Yes or no? Can you see? Four joints. Every element has come in between 9. Now see. Let's name this as 0. This is 0. This is 3. This is 3. And this is 4.5. Can you see only this remain unnamed? Let's say next. Yes or no? Is this the equation nodal? Everyone, this is the equation. Now, when you solve it, x will come. When you solve this, x will come 3 volt. So, and the current through is this clear? Any doubt? Has any doubt? Any doubt?
No, sir.
No, sir.
Let's do one question on capacitor. So, do these questions. Yesterday open circuit. Or that Wheatstone will be in there. So I'll give you this question. How do you approach?
So what's current through 3 ohm resistor?
What will be the current with I? I was the current, right? 4.5 minus 3 or x minus 1. When you do it,
Okay.
x minus 4.5 divided by 2 is minus 0.5. Minus 0.5 means what? It's not outgoing, it is
Incoming.
correct. One name is what?
Yes, sir.
Now, next question, guys. Yes, guys. How will we deal with this kind of problem? See, things will change, na? The formula is different. It's not. Suppose I have a capacitor of capacitance in between 2 points A and B. So, what is VA minus VB? What is right? So, VA minus VB is basically Q by C, which is Q by C, or Q should be equal to C into VA minus VB. So, accordingly, initially in the previous case, what did we do? VA minus VB upon R. Here it is in multiplication. So, थोड़ा सा ध्यान देना है ना मैथ पार्ट. So now see, let's start with the KVL. Now the question is, find the net resistance. Find the net capacitance. Okay. How will you do it? Whenever you do net capacitance, basically you know, what do? You just replace all of it with a single capacitor, right? And whenever we do grouping,
Yes.
we do it like this. You just said this is your C net across the same 10 volt battery. So if I assume that a charge of how much
Q.
charge Q flows through the same way current flow, the same way charge will flow. So the same charge should flow through this and should be on the plates of this capacitor. Okay. So the same way in which you solved this thing. The same way in which you distributed the current, you will distribute the charge. So is it clear? And then
Yes, sir.
ultimately what will you do? Ultimately what will you do? C net will be equal to Q divided. Yes or no? So once you will find out the value of Q, automatically just divide it by 10 and you will get your answer. Is it clear?
Yes.
Okay, let's start. Let me copy paste. So now let's say charge Q flows over here. When charge Q comes over here, what will happen? At this point, what will happen?
To branch.
It will branch. Basically, it will go, one charge will go here and one charge, let's say charge, how much goes over here?
Q1.
Q1. So if I say Q1, so what will be the charge on this plate? Plus Q1, and what will be the
Plus
charge on
Q1
this?
minus Q1.
And the same charge will flow through this. Can you see Q1 will flow in this direction? Yes or no? What about the charge
Yes,
here?
sir.
Yes.
What about the charge here?
Q minus Q1.
Q minus Q1
Q minus Q1 will go over here, so here it will be plus Q minus,
plus Q
and here
minus
it will
Q1.
be minus Q minus Q1, right?
Yes, sir.
Is it necessary if I write this charge is flowing through the capacitor, that applies respective positive and negative will be accumulated? Shall I write all the charges on the plates? It's fine.
It's fine,
Yes,
sir.
sir.
Matlab देखो, if Q1 charge is flowing through this capacitor, so automatically this is understood that this will be the positive plate, so plus Q1 and minus Q1. If Q minus Q1 charge is flowing, so this will be plus Q minus Q1 and this will be minus of Q minus Q1, right? So I'm not writing this charge again. So this Q minus Q1 comes over here. Now what will happen? This Q1 when it reaches over here, it will divide, right? Let's
Yeah,
see.
branch.
Here it goes how much? Q2.
Q2.
And here it will be
Q
Q1
minus
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 Q2.
Q2.
Q minus Q2, right? So this Q minus Q2 will come over here, and this Q2 will pass through this 1 microfarad, and here it
So
will
it'll
be
be Q minus Q2
Q1,
or
right?
Q1.
Q1.
Yeah.
Won't it be
oh
Q1 minus Q2?
my bad. So this will be Q1 minus Q2, or this Q2 will go up. Can you see from here? Q minus Q1 was coming. Q minus Q1, Q2 will be added. So what will be the current charge over here? Q minus Q1 plus Q2. Yes or no?
Yes, sir.
Yes,
So
sir.
this Q minus Q1 plus Q2 will come from here. Q minus Q1 plus Q2. When you add this and this together, can you see my Q1 will get cancelled with Q2, 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 and automatically the same charge is returning back to the battery. Is this clear? Is this clear,
Yes, sir.
guys? Now, when you apply Kirchhoff, how many variables you have?
3.
Three
Three.
variables.
3.
How many equations do you need?
3
3.
equals.
So let's start. Let's start from naming these points. Let's name them. Let's keep that. Okay. Now A, B, C, F. Acha, just always remember, at least mark the charge. You know, mark the charge like which will be positive plate and which will be negative. For example, this will be positive plate, this will be negative. You know? You don't write the charge, what is the magnitude of the charge, भले से मत लिखो, but draw the direction or draw the this. That's the thing I removed. So let me just rub it. I don't know what is happening. So at least mark positive, negative, positive, negative. You are saying the charge is going from here, then positive, negative, positive, negative. Are you getting my point, guys?
Yes, sir.
So at least mark the charges so that you know it's easier for you to remember the convention. Now, tell me what is the charge on the plates of this capacitor? Oh, sorry. Let's go. A to B, nothing. B to C. Are you entering from positive plate or negative plate?
Positive.
So plus minus
Minus Q.
Minus.
minus of
Minus
what is the charge?
Q
Q1.
minus
Q1.
Q1.
So minus
Q.
of Q minus Q1 divided by
1.
yes, correct.
Yes, sir.
उसके बाद are you going positive plate, negative plate?
Negative.
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 Negative plate. So plus Q2
Q2.
upon 1. Then you reach this
Sir, why is it upon 1?
because it's a capacitor, no? Delta V is
Oh, yeah, yeah.
Q by C. The capacitance was 1 microfarad.
Yes, sir.
फिर उसके बाद plus Q1 by 1.
So in capacitor, we don't consider the way the charge flows. Right?
नहीं, capacitor में we consider कि battery के किस terminal से we have entered. Although you can consider that as well. No problem.
Okay.
So in this equation, what are we equating to 0? The sum of the voltage.
No, beta, we are not. Yes, exactly. We are doing the sum of the voltage only. But you know, here in the case of capacitance, delta V is basically Q by C. Q
I don't
equals to,
understand.
you remember this formula in case of capacitance is Q equals to C.
Yes, sir.
What was V? Potential difference, right?
Yeah,
So
potential difference.
from here the potential difference is basically nothing but Q by C. Plus या minus है वो Kirchhoff से अपन को पता चल जाएगा. Using that only. अरे we did I into R, no? In
Yes,
the case
sir.
of capacitance, we did Q by C. Ulta.
Okay, so in any closed loop, the potential difference is 0.
Yes. Across all
We're
the elements.
considering that.
Across all the elements. है ना, in a loop. The sum
Sir, I
of
have a
potential.
doubt.
Yes, tell me.
Like the first minus Q1 by 1. Why is it minus?
Where? Here. This one.
Yes, sir.
Because you are entering from positive terminal of the battery, positive terminal
Okay,
of the
sir.
capacitor. Here negative terminal of the capacitor. Here also negative terminal of the capacitor. That's why these two
Okay,
be
sir.
plus and these two be minus.
Okay, sir.
So this is the first equation. Next equation, guys. Yes, next equation. TDAC minus
Yes,
Q2.
minus.
Minus
No, no,
Q.
minus Q minus Q1 plus Q2.
Q1
Anything
plus
charge
Q2.
divided by 1 plus Q1 minus
Q1 minus Q2.
divided by 2. Okay, plus minus divided by. Can you see the charge over here, Q2, and we are entering from positive, hence negative over here. So it's just like the same equations are made, but थोड़ा सा carefulness के साथ में, because we people are generally very fluent in drawing the V equals to IR Ohm's law, easy. But for capacitance it's Q is equals to CV, तो उल्टा बन जाती है equations. So these are the two equations. Make one more equation and then solve. अच्छा, my personal advice: choose the outer loop. A, F, E, to the battery. Okay, so basically this loop, so A, F, positive terminal to minus Q1 by 1, then positive terminal to minus of Q1 minus Q2 by 2, then negative terminal to plus 10. Once you are done with all these three equation solving, you will get the value of Q equals to something, Q1 equals to something, and Q2 equals to something. Please note, since you put the value of here microfarad, can you see over here everything is in microfarad? So your charges will
Into
come
10
in,
raised to minus 6.
Microcoulomb.
every charge will come in microcoulomb. So once you got the charge,
So we
yes,
don't have to write into 10 raised to
no, no,
minus
no,
6.
it's okay. In the answers you will
Okay.
include directly.
Okay, sir.
Because when you take, this as microcoulomb, so can you see microcoulomb, microfarad automatically gets cancelled and becomes volt. So can you see volt added over here? So that's it. Is this clear?
Okay.
Once you
Yes,
get
sir.
the value of Q, you put this Q over here and find out the C net.
Mm.
The same way we can apply nodal analysis as well. But please remember, we will not be using VA minus VB upon R. We'll be using this. Okay. You don't need to distribute the charge or anything. You just simply need to do nodal. Is this clear, guys?
Yes, sir.
That's fine. Solve कर लेना equations. I'm not solving as of now. No need to distribute the charge or anything. Just the node. Only these four. Yes. Yes or no? So now this will be 0. This will be 10. I don't know these ones, so I'll name this as X and this as Y. So initially, if they would have been registered, I would have written what? X minus 10 upon 1, right? But they are capacitance. So I'll write total outgoing charge 0. multiplied by x plus 1 multiplied by x minus 4 plus this one multiplied by x minus 0. From here you will calculate x. Yes or no?
Yes, sir.
Hey, this is not x minus 4. This is y. My bad. But this is x minus y. Okay. This is your one equation. And the second equation will be 1 multiplied by y minus 10 plus 2 multiplied by y minus 0 plus 1 multiplied by y minus x. So from these two equations, we get the value of x and y in volts. Is this clear? And once you got that, you can easily find out what is the net charge over here. What will be the net charge over here? Tell me what will be the net charge over here. Can you see this charge Q which will go over here? It will divide into this and this, right? So can I say this is Q1 and this is Q2? So C net will be equals to Q by 10, which will be Q1 plus Q2. And this will be Q1 plus 10 minus x multiplied by 1. That is Q2. So, now how to do it? Just put the value for x and y. Get that.
So
Yes, tell me.
what are we doing? What is the C net is equal to?
We need to
How do we find?
calculate the net capacitance.
Okay,
Net capacitance is basically C net is Q by V. The battery is potential, right?
Okay.
We will do. Don't worry, I'll give you similar question on resistor as well. ये वाला भी type
So
clear
can
है.
you explain the nodal one again?
Can I explain the
Yeah,
nodal one? Sure. Can you see? First step which I did was to mark all the joints. Okay. When I did
Yes.
that, all the joints are marked. Now, can you see this negative terminal of the battery was connected to this, so I named it as 0. And the positive terminal was connected over here, so I named it as 10. This 10 couldn't go over here. This 10 couldn't go over here. This 0 couldn't go over here. And this 0 couldn't go over here. This cannot go over here because of the capacity. So hence, I have to name them separately. So I named this as x and this as y. So two equations, two variables I wanted. Once I got this, can you see the total outgoing charge is 0? Charge is equal to capacitance multiplied by potential. So, what is the potential difference? X minus 10 multiplied by the capacitance. 1. So 1 into x minus 1. 1 into x minus 1. 1 into x minus 0 equals to 0. Similarly,
So where did you get x minus 0 from?
x, ये वाली branch, x minus 0. This one, x minus 0.
Okay.
Are you able to see the branch which I have mentioned?
Yeah.
This x minus. So this is how you apply. You know the same rules are right, but four are different. Just a slightly changed thing, but the rest everything is same. The concept is same. The application is same.
So in the y minus 10 in the second equation that you've written, right? So like we're assuming current goes from the potential from 10 to y, yeah?
Actually
Like-
it is going from 10 to y, but do you know the value of y?
No.
So since
So-
what are you doing with at point y, you are applying total outgoing charge is 0. Although when we'll calculate, you'll get y minus 10, right?
Yes, sir.
So y minus 10, it will come negative, right?
Yeah.
So I know it will come negative, that's why. But
Okay. Yes, sir.
चलो, any doubt? थोड़ा बहुत practice लगेगी कहीं, इतनी जल्दी clear नहीं होगा. But anyways, write the heading. Guys, write the heading. Write the heading Wheatstone Bridge. Okay. So this is about your KVL and NODAL. Now we'll be doing Wheatstone. So Wheatstone Bridge. First of all, what is a Wheatstone Bridge? It's an assembly of 5 resistors as shown. है ना? So I'll show you what exactly is a Wheatstone Bridge because अभी थोड़ी देर में we need it. क्या हुआ? हाँ? हाँ, नहीं लेके आए क्या? मेरे को नहीं पता. चल. Right up. And I'll just draw this for you. Like everyone have studied this thing in their schools, right? Guys, where have you done till here? Acha, by the way, how many of you need any extra class on this thing? Magnetic effect of electric current. For those people, I'll just teach school level things. For those people whose this chapter is coming in the school tests and all. Guys?
So could you take an extra class for
Yeah,
these?
I'm planning that only, but I'm planning on this Monday, the next week.
Monday.
How many people have that included in their unit test and all?
I have included.
I do.
I have it included in my test, sir.
Okay, Ovia, so you told me. Whether you also told me, right?
Yeah.
So even I have it.
So what chapter?
So even I have.
Magnetic effect of electric current. So please,
So we don't have magnetic effect of electric.
In the test you don't have, no?
You mean moving charges and magnetism?
That moving charges and magnetism. Yes.
Yeah, that one.
I named that chapter as MEC. Moving charges and magnetism is MEC for me. Magnetic effect of current. उसमें moving charges ज़्यादा था. Okay.
I also have like a question for school level exams. Is it okay if we just do past year board questions?
They will be more than sufficient.
Or would you recommend doing guides like exam?
ना इतना guide वाइड की जरूरत नहीं है. पर school में class में मैम ने जो do. I'll tell you the important stuff. Use.
Okay, fine.
सबसे पहले first the Biot-Savart law and its application.
Okay.
A very long straight wire, a circular wire.
Yeah.
A solenoid, a toroid. So do all those derivations based on Biot-Savart law. Okay.
Sir.
After that, the force on two current carrying parallel wires. Two current carrying wires which are placed nearby each other. They apply force on each other, right?
Yeah.
That is very necessary. Then the cyclotron thingy. Okay. Cyclotron is based on how the charge rotates in circles, right?
Yeah.
So definitely one question will be based on that. And
derivation. पूरा उसका derivation करना है.
उसका derivation or at least remember the formulas. What is the angular velocity? What is the normal velocity? So no problem. I'll guide you in the extra classes I'm planning. So most probably it will be on Monday. I'll drop a group on the I'll drop a message on the group. So whoever wants to join, they are most welcome. Achha, by the way, what should be the timing? Timing kitna rakhu main? When does your school ends?
2.
Everyone 2 o'clock it ends.
Yes, sir.
I have school until 3:40.
You have school till 3:40. Ishita, is that chapter also coming to your school as well?
Yes, it is.
क्या करें बताओ?
So will you be teaching the entire chapter?
I'll be teaching just the main important stuff.
Okay, sir.
At least it will be like you'll have something, whatever doubts you have, sir, I'm not understanding this derivation, I'm not understanding that derivation, I'll be just discussing those only. The derivations which you people will tell me, sir, I have a difficulty in this derivation, so please explain. I'll be doing that. I will not be teaching you the whole chapter. Okay?
Be teaching it again, right? Like,
What?
you'll be teaching the chapter
Yeah, yeah.
again.
No, normal classes, yes. That is just a school level thing. So that at least your
Okay.
school level you can do something which is based on MEC. Okay?
Or
Okay.
sir, you can record the class and then if I have any doubt, I'll ask you.
See, I'll do one thing. I'll अच्छा पर तू तेरी 3:40 पे class खत्म होगी, right? So you'll have have some food and all. Is it possible if I'll record the class, don't worry. And do one thing. जैसे तेरी school खत्म हो, take your lunch, sit in the class, खाते खाते पढ़, कोई दिक्कत नहीं.
Yeah, okay.
Okay?
Yeah. Yeah.
So, Shri sir, my physics test is on Monday itself. Okay. अच्छा, Sunday is it fine? Guys, Sunday. Sunday.
Yes, sir. No.
Yes, sir, it's fine.
Because you don't have any classes and all, right?
Yes. No, sir.
No,
तो
sir, we
फिर
don't have it on Sunday.
Sunday को कर ले. Shirish, is it fine by
Okay,
you?
sir.
Ikshita, is this fine by you?
Yes, sir, Sunday is fine.
चलो ठीक है, फिर we'll book one class on Sunday, 2 hour slot of doubt session and doubt and discussion, derivation mainly, many derivation and questions. Okay. And the prerequisite is you should be done with the chapter first. Whatever doubts are there, just ask me that. Sir, I am having a problem in this derivation, in this question, or in this, whatever it is. Explain me this. So I'll be doing that. है ना? मैं पूरा शुरू से आखिरी तक chapter का each and every derivation I won't be able to do in that 2 hours because it's a big chapter. Okay? It's a unit. That
So
chapter
we
is
have
a
to do
unit.
derivations and stuff also.
Derivation you need to do it now.
Okay, fine.
Could you teach the last part of this chapter as well, like the potentiometer and stuff?
Electrical instruments. Okay.
Yeah.
Done.
So and can you also take the last the fifth chapter? What is it called?
Magnetism and matter.
Yeah, that one.
बेटा वो थ्योरी चैप्टर है, खुद से पढ़ के कर सकती है. तो पैरामैग्नेटिज्म, फेरोमैग्नेटिज्म,
सर वो मुझे समझ में नहीं आया सर, उसमें बहुत वेगली बताया हुआ है उसमें जो
वहां से मत पढ़ उसको इधर see some videos on YouTube और वरना फिर मेरे नोट्स भी तो मेरे पास नहीं है. Only this chapter magnetism and my notes are incomplete.
जो H and M है ना वो बहुत वेगली एक्सप्लेन किया हुआ है उन्होंने.
मैग्नेटाइजेशन एंड मैग्नेटिक फील्ड इंटेंसिटी
उन्होंने बहुत वेगली एक्सप्लेन किया हुआ है, मेरे को समझ में नहीं
वो ऐसा ही है बेटा, सही में ऐसा है. मैग्नेटाइजेशन और जो मैग्नेटिक फील्ड है ना, दो अलग अलग चीजें हैं, पर उसको इतना गंदी तरीके से एक्सप्लेन करते हैं. पर एक बार देखना, वरना मैं तेको कुछ रेफरेंस मटेरियल देता हूँ जिसमें अच्छी तरीके से एक्सप्लेन हुआ.
ओके सर, ओके, थैंक यू सर.
चलो, नो प्रॉब्लम. So first of all, when we talk about a Wheatstone bridge, it's the assembly like this. Can you see 4 resistors over here? Yes or no? Guys, can you see 4 resistors between A and B?
Yes, sir.
So where do you think the 5th resistor should be connected? It
In the
is
middle.
connected like this. Can you see this resistor? Let's name them. This is P, this is Q, this is R, this is S, and this is T. So can you see this T wala resistor? It's connected between points. Let's name them as X and Y. Can you see X and Y?
Yes.
Yes, sir.
If this
Yes, sir.
point would have been, if this resistor T would have been connected in between the A and B, then this question would have been very simple, right? If this T would have been connected like this, then this question would have been very simple.
Yeah.
How will we solve this question?
P
P
and
and
R
Q are
in
in
series.
series. No, wait. P and R are in series.
P and R in series, Q and S in series.
Q and S
all
in
three are
series.
All are in parallel.
parallel. But this is not your Wheatstone bridge. This is your Wheatstone bridge. The A and B are there, 4 resistors like this, but in between the two, you will just connect them by a resistor. This assembly is basically called as a Wheatstone bridge. Why is it called as a Wheatstone bridge? Because this assembly was first discovered in a I think there was village. There is some village. क्या हुआ भैया? What happened? Hello?
No, sir, my sister.
I got scared. What is this, man?
That ma'am was in unmute.
Oh my god. मेरे को एकदम से वो ये क्या हुआ? What just happened? But anyways, this is the Wheatstone bridge, guys. Okay. What is so important about Wheatstone bridge is the balanced condition of Wheatstone bridge. We'll come back to the balanced condition of Wheatstone bridge. First of all, I'll draw the alternate circuits. It's like Wheatstone bridge is very easy to be drawn, but there are other methods in which you can draw this circuit. Alternate circuits for Wheatstone bridge. Everything which I'll draw is a Wheatstone over here. For example, this is simple looking. Is this very simple looking Wheatstone? It looks like a ladder of sort, right? Yes or no? Is this a Wheatstone?
Yes, sir.
Yes, sir.
This A can, I can, move this A over here. I can move this B over down, wherever I want over this line, right? So this is your B, Q, R, S, T. This is point X. Acha, let me just, write the point in black so that you will not get confused between the points and the resistance. Okay. So the ones which are written as black, they are the joints. Okay. They are the points across which the resistors are connected, whereas PQRS are resistors. I didn't want to use that. What do we call it? The R1, R2, R3 representation, because that's very not very good. Anyways, acha guys, even this is one of the form. I'll do you remember this?
Yes, sir.
But in spite of a connecting wire, I am just placing two different resistors over there, A and B. So can you see over here? Let's say this is your A, this is your X, this is your Y, this is your B. Okay. Is this clear, guys? A, B, X, Y. Tell me which resistor was there between A, X and Y? Between X and Y it was T, right? So always remember this one is T. Which resistors was there between A and X? A and X.
P.
P is over here. Q is over. This is Q. Can you see A and Y? Yes or no? A and Y. A and Y. Is this clear? Yes or no, guys? Is it clear?
Yes, sir.
And which resistor is in between X, Y? Oh, sorry, X, Y to ho gaya na? X and B. X and B.
R.
So this is R. And Y and B.
S.
So can you see over here? There is one condition which is basically what P by Q is equals to R by S. Then something happens.
Then no current flows through T.
Yes.
Yeah,
Then
no current flows through T.
So can you see in this case, how will you read this thing? Can you see P by Q is equals to R by S, like this.
Mm.
How will you read in this case? P by Q is equals to R by.
Is equal to R by S.
Here you will read like this. Okay. Q by P equals to S by R. Is it one and the same thing?
Yes, sir.
Q by P equals to S by R, one and the same thing. You can read it like this or like this. It's up to you. But read like this. Anna? Other form, one more form is there. I'll draw that form as well. First, we'll do the balanced condition today, and at least I'll give you the proof of the balanced condition. And this is also Wheatstone. Sir, how is this Wheatstone? Can you see points A and B? Guys, can you see points A and B?
Yes.
This is X and this is Y. So this is basically the P, the Q, the T, the R, the S. Okay. So how do you read it here?
Do your wire method over here to figure out like how it's Wheatstone.
Which method?
Diagram. The wire method that you showed to figure out the potential.
Yes.
So we can see
Yes. SS method. Yes. You
Yeah,
do it
SS
over here.
Okay.
नाम दे, क्रेडिट दे, बहुत मेहनत से बनाया, तीन चीजें मिला के.
Sorry, sir. Shiv's method.
So P by Q and R by. Is this clear, guys?
Yes, sir.
So these are your alternate circuits for Wheatstone bridge. Draw them all. Have you drawn them all?
Yes, sir.
Except this one, I think. Let's do the balanced condition of Wheatstone bridge. First of all, I'll teach you what exactly is the balanced condition. Then we'll do the unbalanced one in the next class. And I'll be done with Wheatstone. After that, Wheatstone, what will be there? We will have a symmetry, a reverse symmetry, and
So I had a doubt.
yeah.
Wheatstone bridge can be applied on capacitor also?
Yes, no problem.
Okay.
Okay. Guys, only 2 or 3 things are there. And there is one more which is called as Thevenin. Thevenin is not there as a part of your school syllabus, but it makes your life easier in solving the circuits in which resistance and capacitors are together. Okay? We call them RC circuits. So, we do it. Anyways, heading देखो guys. The balanced condition I think I'll be not be able to give you the derivation, but at least we'll do the condition. What is the condition? Okay. Now, see, whenever you have any Wheatstone bridge over here, A, C, C, Q, hello. Guys, shall I need to explain again how is this Wheatstone key clear a Wheatstone bridge is this diagram? Huh? Now see what is the balance condition. According to the balance condition, ratio of resistors on both sides of the bridge. I call this as the bridge, okay? It's not actually called as a bridge. I call this as the bridge so that it's easier for me to understand कि bridge के एक तरफ, bridge के दूसरी तरफ, right? So can you see over here? Bridge के एक तरफ, bridge के दूसरी तरफ. One side of the bridge, another side of the bridge. One side of the bridge, other side of the bridge. It doesn't happen in this case. Both are on the same side, but can you see? I can hold this A and rotate this, keeping XY as the axis of rotation. Guys, can you see
Yes,
this? I can hold A and rotate the circuit about the line XY. Keeping XY as it is where it is. I can rotate A, right? I can open it up. It will become the same. So is equal, that is E by Q is equals to R by S. Then the potential of X and the potential of Y will be. Is this clear? Vx equals to Vy. Shall I write it in words? Guys, shall I write it in words? It's fine.
It's fine, sir.
Okay. So then Vx and Vy will be equal. If Vx and Vy are equal, that implies the potential difference between Vx and Vy is 0. That implies
0.
no current flows through. Also note, whenever no current flows through any branch
So could you explain why Vx will be equal to Vy?
that will derive in the next class. Or with this condition we'll derive this. With this condition we'll derive this. Okay.
Okay.
So whenever no current flows through any branch of the circuit, there is no point of keeping it. Throw that branch out. Simple concept. If no current is flowing through T, so what will happen to this circuit? What will happen to this circuit? P, Q, R, S, A, P, X, Y. If P by Q, if balance condition होती है, then remove this P. Throw it. If you remove it, it will become like this. It becomes P, R, Q. So now, can you see from here what is the net resistance? How will you calculate the net resistance? P is in series. Yes, guys. How do you calculate the net resistance now?
So P and R are in series.
P in series with R. Q is in series with S. Please note, now you know these two will become in series, not these two. है ना? Note very well, है ना? P and R will be in series and Q and S will be in series. I told you how to identify P, Q, R, S, है ना?
Yes, sir.
And the series
Yes, sir.
combination of P and R will be in parallel with the series combination of Q and. This is how you will calculate the net resistance across. Is it clear?
Yes, sir.
So this is your balanced condition of Wheatstone. We do some questions in the next class. We'll prove this condition using Kirchhoff, especially, or nodal, whatever you say. I don't mind. Is this clear, guys?
Yes, sir.
And after this, I need to teach you open circuit Kirchhoff as well. Kirchhoff can be applied to open circuits as well.
Open circuit?
That is called as open circuit Kirchhoff equation. So
Like with no current flowing in them?
Huh?
With no current flowing in
Nah.
them?
Current is still flowing. But you know, you
Okay,
will
maybe
still
if we're
will
talking
be
about
calculating the
capacitors, then
potential
we can
difference
say
between
that.
2 points. Between any 2 points. Okay?
Yeah, okay.
Chaliye. We'll see you again in the next class, guys. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah, I'll drop a message regarding the class on.
Thank
Okay?
Yeah, sir.
you, sir.
Thank you, sir.
Thank you.
Thank you, sir.